You've been solving systems of equations with three variables, and we worked through example 2, but I want you to also notice here in example 3, we have something similar to what we had in example 2, where we have our three equations, x plus 2y plus z equals 14, and then y equals z plus 1, and x equals negative 3z plus 6. Again, these last two equations in our system only have one variable on the right side of the equation. So what we're going to do is substitution again. I'm going to take the z plus 1 and I'm going to trade that in and substitute for y in my original equation, or my first equation. Then I'm going to take negative 3z plus 6 and I'm going to substitute that in for the x variable in our first equation. And of course, once I do that, I'm going to have all the same variable in my equation. I'm going to trade out the x and put in negative 3z plus 6 in place of x plus 2 times the z plus 1. I'm going to trade that in or substitute that for y. 2 times z plus 1, the quantity, and then plus z equals 14. Now I'm going to distribute the 2 times z plus 1. So I've got negative 3z plus 6 plus 2z, and then plus 2 times 1 is 2, plus z equals 14. Now let's simplify over here. We're going to, on the left side, we're going to combine negative 3z plus 2z plus z. Well, negative 3z plus 2z is negative 1z plus 1z, all that together is 0z. Then I'm going to add 6 plus 2, and that's 8, equal to 14. Well, 0z is just 0, so I end up with the equation 8 equals 14. Is that true? No, that's not going to work. 8 does not equal 14. If we work this out and we come up with a false statement, that means that there is no point that will satisfy all three equations in our system. So therefore, we say there is no solution. You can either use the symbol for no solution or write the words no solution.